Hi everyone, this is Thomas of Polyga. I'm going to do a quick tutorial on how to reverse engineer this prismatic part that a friend of mine sent me. He wanted me to show him how I would approach doing something like this and how to create a CAD file using XTract3D. So I imported the data in. As you can see right off the top that the coordinate system begins at the bottom left. That's where they left it. But the orientation of the part looks to be pretty good. That part's correct. So I can kind of use our move tool here. I'm just going to move the mesh. I'm going to just tell to auto center the mesh, and it's going to center the mesh along to the center of it. Rotationally, it looks to be good, so I'll just leave it as is. And I'll show and hide these planes, and it gets to refresh. And you can see now the part is now centered onto the this part. The way I'm going to approach this, I'll probably sketch it from top down and then do a cut along the length of it to get the fillet, get all the edging right. So first things first, I'm going to take my top plane and I'm going to pull a slice off of it. It's not quite where I want it to be, so I'm going to move it down to about here, which gives me a better view of how I want to draw the sketch. So I'm going to leave it there. I'm going to pick my top plane and start a 2D sketch on it. From here, I just really need to see the red outline. I don't really need to see the mesh, so I'm just going to hide it. I'm also going to hide these three planes so it doesn't stay in my way. And there I go. This is the outline, and all I have to do is draw my lines around it. So by and large, I just need to do this. And what I do is I can pick my line and tell it to fit. And that's a nice way to just grab a quick line and fit it onto there. And I'm going to use that line as my base because one of the nice things about doing this whole thing in SOLIDWORKS, there's a difference between just copying the data exactly and taking this data and creating a new drawing with actual design intent. So I'm going to fix this line, and that's going to be the root line that I put everything relative to. So I'm going to pull a line off of this side, pull a line off of this side, and pull a line off of there. So in all these cases, I can choose these three lines, tell it to fit, and it's just gonna snap onto the line that I've got. But because I want to do some design intent with this, it's just not to snap it onto it. What I'm going to do is create relationships. So this one's fixed. So what I'm going to do is set that line to be perpendicular to that line. So they're perpendicular. I'm going to set. Then I'm going to set this one to also be perpendicular, and then these two to be perpendicular, or these two to be perpendicular as well. So even though the original positions, everything is snapped, I want the orientations to be all perpendicular, so I have a nice square part, because that's how I actually want my design to come out. So once that's done, I'm just going to extend the points of this a bit. Oops. I can also fix this if I don't want it to drift, so I can just extend the lines out. Fix that as well. I'll do the same thing here. So it's a nice easy way to get all the edges right, and I'm just going to power trim these corners away. So next thing is doing these fillets. I don't want to draw separate ones. I actually want them all to be the same. So actually for these edges, I can either draw a arc for it, or I can just use a fillet and match it closely. So in this case, I just want to fillet it actually because I like it. So I want all the corners to be exactly the same. So this is pretty straightforward. 1.7. So it looks like it's between 1.7 and 1.8. So I'll probably put 1.75. Not quite. 7.6. That gives it pretty close for me, and that's what I'm going to do on that fillet. Let's see if I can. I'll do the same for all four corners, 1.76. So it's nice and consistent. So my design file is actually consistent. It doesn't just blindly follow the scan data. So next is the holes. So I'm going to draw a circle here. Grab that, fit it on there, and it fits in nicely. For these ones, I don't really care about the design intent of it that much. So what I'm going to do actually is just grab each of those circles, move it in place. I'll grab these four, tell it to fit. Grab this one, tell it to fit. And I'm done. I've got my sketch that I'm looking for. So let's have a look at our mesh again. So next thing I want to do is probably just extrude it up and down to the plane. I can just pick a point, or I can create planes. So normally I just like to do a point because it's quick and easy, but in this case I want it to be a little bit more accurate, so I'm going to create 2 planes. And we have a plane tool here, and I can do it by just sampling a handful of points that I'm really interested in. So that'll be 1 plane. So that will be I can rename this to part top. And I'll create another plane using the plane tool in XTract3D. Done. And this one I will rename to part bottom. So take the sketch, features, extrude it up to the surface, to the part top. Second direction will be up to surface, part bottom. And shebang, we're at least halfway there, I think, already, which is we have a part that at least goes, that approximates the shape of what we start off with. So first things first, let's hide this. The big thing now is to cut out this portion of it, this portion of the part, so that it looks closer, I guess, to the actual part. So we'll do that next, which is we'll draw a part where we cut this out. So that's our solid that we've got. So what we need to do next is get that cross section. So I'll start with the right plane here, and I'm going to do a sketch along the right plane. So I'll do a slice of it. It doesn't show me actually the information I want, so even though it's where I do my sketching, I'm just going to move it over. If you want to use more than a single sketch or a single profile to do your sketch, for example, if you want to pull an average, there's a multiple slices functionality, or you can do multiple linear slices or multiple rotary slices to gather additional information to do your slice. So for example, on here, let's do that again, the sketch, you can do multiple slices. You can do a increment of maybe 7 and apply. It's really big. Yeah, so you can do multiple slices and tell it to merge back as well, so that you can take information from multiple, essentially these multiple 6 slices, and have it merge back into a single outline for you to sketch off out of. And I can actually do it here. So you can see the data is actually super consistent, because I actually took 6 slices along this, and when I projected it back, they're pretty much right on top of each other. So I'm gonna go okay with that. I like that. And along my right plane, I'm gonna start a new sketch along my right plane here. Just so things are a little bit easier to see, I'm going to hide my solid as well as hiding the mesh. So all I'm looking at is this outline right here. And what I'm going to do is do a sketch where I can use it as essentially a cutout. And the line's extra thick because it's actually an average of all those slices that I took from earlier. So it's relatively easy. I can use the same tools even though they're stacked on top of each other from here to either fit it on or to just snap it on. So fitting it will just project and add the point into the average of all these lines, as you can see here. So that's that tool. So this is pretty straightforward. We'll which is just a cut tool here. So these arcs are a little bit of a pain, but I can fit it just to get it right. I'll fit that one there as well. By and large, this process is pretty straightforward to do. And there's always some interpretation too. Right now I'm not doing any design intent. I'm not actually redesigning this. I'm literally just copying it and not really paying attention to see if the numbers are round numbers or they make sense or anything like that. I'm just trying to get a close approximation so I can create a CAD file from the scan data. I'm not trying to generate a real CAD drawing out of this. The process would be a little bit different if I really was trying to do something more intense, I would say. So that's pretty good for an initial outline, I think, for me. So what I'll do is now do the cutout using this information that I've got, and essentially this will give me an outer cut. So there you go. Let's have a look at everything again. So that's pretty good for a, I think, initial cut of this part. So we'll do an extrude cut using this way as well as that way. And there we go. We have the second part of this, which is the extrude cut. So it's already looking pretty close to the solid's actually looking really close to the scan file. The big thing that's missing now is this little cylinder-like thing here. So next up, we'll model that cylinder thing and merge it in. So I'm going to take my part top, the plane that I had earlier, and start a sketch there. You can see from the part top, the data pulls off isn't ideal. So I'm just going to move it up a bit. So the way I'm going to model this is, I don't know if this is actually an exact circle. It looks real close to a circle, but I think it's more of a dome shape. So I can't just fit a circle on this. I'm going to have to draw this out. So what I'll do is extract the center axis from this, and then take that center axis and do a revolve, which is pretty straightforward. So I'm going to take the top of the way I'm going to do that, I'm just going to take the top part, slice it, move it up a bit, and create a circle right there. So I'm going to slice, from the part top, I'm going to start a new sketch from this side of it. And what I'll do is create a circle. There we go, take the circle, fit it in. I'm done. And what I want next is to create an axis. So the way I create the axes is out of these features here. Take an axis, take the center of that, and then made the top bottom. Yeah, top bottom would work, I think, as the face, and say yes. I don't know why it makes this line so big, because I certainly don't want it that big, but it is. Yeah, so there I go. Got the axes with that right there. So what I want to do now is to create a plane along this axis, which should be easy enough. So what I'll do is create plane, choose the axis as my first reference, choose maybe that plane right there, and tell it to be 90 degrees to that plane, to the right plane there. And that gives me a plane that I can draw and sweep around. So there I go. I've now got a plane here that I can do a sketch off of. So grab that plane, slice using my new plane, and now I've got a nice little cross section of that, as well as an axis that denotes where my center line is. So that looks pretty good. So I'll start a sketch on the circle here. Sometimes the default angle is kind of weird, but that works. And I'm gonna hide my last solid too, because it makes my life easier to really just look at the outline, because that's really what I'm interested in. So there we go. I've got a little construction line here. So what I'll do is first when I start to sketch, I'll just do it from this angle instead of having to do it again. First thing I'm going to do, I'm just going to draw my center line. So that line is going to be my construction line in 2D. The other axis is in 3D. That's why I kind of have to do it again. I'm sure I could use it, but this is easier for me. So now I'm going to draw this part out, and this part is relatively straightforward. It's really just from here. It's really just two arcs. So there I can just fit the arc in, and that looks pretty good. And I'll do the other half of the arc. You could use a spline for this as well. Fit it, and I want it to look nice and smooth, so I'm going to make the tangent. And I think I'm going to pull it back a bit till it's always tricky to try to keep tangency while I'm keeping the shape right. So all we have to now do is take this sketch and do a quick revolve. And you can see, there we go. There's the revolve along the center axis. That's what we're going to use. And now we're done. So in the interest of time, and also being able to show off some of our comparison tool, what I'm going to do is, instead of finishing these off, I'm going to do a manual fillet of these edges by hand instead of referring to the scan data. So what I'll do is start my fillet tool. Just grab this edge. So let's see. I'm just going to choose a value that just happens to look good. So I'll fillet it by 0.4 to get a fillet of the data. I can see that it's a little bit off from the scan data, but that's okay because that's what we want to show off. So at this stage, what we can do, if we want to compare back to the scan and get an idea, we just choose our mesh, go back to XTract3D and do a mesh deviation. What it's now going to do is going to take our mesh and then compare that mesh to the CAD file that we've got. Here we go in terms of the comparison chart for the scan. You can see actually the part that's probably the furthest off is the circle, so we must have missed there. And this area here wasn't too bad because I guess we eyeballed it pretty good, but this area is pretty bad because we did absolutely no filleting of it in the CAD file, whereas in the scan data, obviously there's a lot more in there. So it's a kid's idea. The rest of it looks pretty good. I think this is a really simple part that was geometrically almost perfect. So when we did the CAD of it, pretty much everything was good. To kind of have to copy this thing. There you go. So there you have it. The we have our CAD part to the left, and with the scan part that we originally started with on the right. Hopefully this gives you a good idea of what it takes to generate a CAD file from a prismatic part like this. As you can see, it's relatively straightforward, but you do need to do some planning on exactly how you're going to produce your drawing and how to get all your edges smooth and your solids continuous. Anyhow, thanks a lot for your time, and I hope you enjoyed this little demonstration. Thanks.